next up, this function, graph in the window, causes hidden behavior find experiment to find the extrema. Okay, what does that mean? Okay, extrema are the mins and maxes. I guess the ES. Minimum and maximum. So it looks like right here something's going on, but we don't really know exactly. It looks like there might be a max right here, there might be a min, or it might be flat. We don't know for sure. So what we're going to do here is we're going to put this in our calculator as it suggests. And we're done with this problem, so we'll erase it. So sometimes I like to help the calculator out a little bit because there's potential for error. You might put, because of PEMDAS errors. When it's simple enough like this, I'm just going to put 0.5x. Now, so that way the computer has no confusion about what it's doing. So 1/2 x to the third power minus 2.5 x squared plus 4x plus 4. I double check it, and that looks right. Now, this one good thing to do whenever you graph is you go to zoom and you want to reset it, zoom standard. So that's a good, if you've been exploring already, this sets it to -10, 10, -10, 10. Now this is what we have here, and we want to know what is going on right here. So it looks like this is between 0 and we'll go to 4. And 1, 2, 3, 4. From 4 to 1, 2, 3, 4. We'll go to what was that? 4 to 8. So we're gonna go to our window. Our minimum is gonna be 0 to 4. So that's from here to here. And our minimum is going to be y equals 1, 2, 3, 4. We're going to go up to 5, 6, 7, 8. So from 4 to 8. And we'll graph that. So that's basically a graph of this area right here. Now here we can see more clearly, that there is a maximum right here and a minimum right here. So what we're going to do here is, but it's not exactly at an integer point, or it might be, but it doesn't look like it is. So we're going to use our calculator again. Now the only way to do this without a calculator, a graphing calculator, is to use calculus, and of course this is not a calculus class, so you pretty much have to use your graphing calculator to do this. So we're going to find our maximum. The left side of the maximum. Now, if you can notice these numbers here, we want these to go up because we're going up the mountain right here. And we want to know, when do we start going down? So it's 6.07 and 6.07. Okay, now we're down. Now to make this obvious, I'm just going to go a little bit more. But we're clearly on this side. If you can't tell by the graph, you can tell by the numbers here. So we're at below 6 here, and we're going to go over the hill. So 6.07, and we're already going down, and this is clearly less than 6.07. The maximum should be somewhere in here. And guess, we'll just go a little bit over, we guessed somewhere over here. So the maximum, it looks like it's 4/3, 1 1/3, and a 6.07. Now, what wants 2 decimal places? So our answer here is, well, the answer here is, I'm going to copy and paste this to make it clear. And think here is the maximum right there. The minimum is, now we go to second calc minimum number 3, and we go over somewhere over here. So I think it's going to be somewhere right here. You can look at the numbers again. Oops, something went wrong here. Second calc minimum. Okay, now we're going to choose the left bound here. We're going to go to the right bound. So notice that right here it's about 6, and we're trying to go up again. So I'm clearly on the upside. I'm going to be on the valley. And we guess it's somewhere in here. It doesn't have, the guess doesn't have to be accurate because it'll find it. The minimum looks to be at around 2 and 6. We're going to copy this over, and I'll even copy it so it shows what it is. Oops, I think I went. Let me do that again. Okay, so our answer is this. We'll delete that. So our maximum is going to be, let's put this over here so you can see it. Our max is 1.336.07. Our min looks like 2. Yeah, they'll say 2 also, 2.6. So there's round off error here, but 1.9999, I mean, that's pretty close to 2. So that's our answers. Use the end behavior diagram to describe the end behavior of these graphs. So to recall the end behavior, there's 2 things we're interested in. It's the degree. Over here, we care if it's even or odd. And over here, it's the leading coefficient. Coefficient is either positive or negative. So that's what we're going to get here is degree. If it's even and positive, it's going to be this one right here. So it's going to be if it's even and negative, it opens downwards. Now what this means is as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. And so on. So odd means the end behavior is opposite. And this one is going to be this way and that way. This one starts that way and ends up going that way. So this is all we need to look at here. So let's move this over here. So for here we have the degree is the highest degree here. So it's 3. So being 3, it's odd. It's one of these cases. The leading coefficient is positive. So this is going to be this like that. So basically, actually the answer key just says this is good enough. So this means as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. This one, the greatest degree here is even, so we're over here. The leading coefficient is negative, so this one's going to be, it's like a downward opening parabola. And we'll start anew.